All right, we've got a really old series problem that's actually a fairly straightforward problem, and that's one of the reasons why we have you practice it, just so you could get used to doing the more straightforward type of work. So they're giving you the initial value here and then a series of derivatives. We have to keep in mind that for a Taylor polynomial, we have three components to each term. We have the nth derivative at the center, we have x minus the center to the n, and we have n factorial in the denominator. So part A that wants a second degree Taylor polynomial. The second degree is three terms because the first term is the 0 degree. That is just the number 3. Plus we have the first derivative, which is negative 2, times x minus 1 to the n over n factorial. And we are centering at 1 because they've told us that in the problem here. And then the third term is our second degree term. We have a second derivative of 2, and then we have x minus 1 squared over 2 factorial. And let's clean this up just to make life easier. This will become 3 equals negative 2, not equals, sorry. Let me go back there. 3 minus 2 times x minus 1 plus, and then nicely these 2's cancel. So we just have x minus 1 squared. So that is our second degree Taylor, and we are going to use it to approximate f of 0.7, which will give us 3 minus 2 times 0.7 minus 1 plus 0.7 minus 1 squared. And yes, I can work this out if I want to, or I can just leave it exactly like this and get full credit, which I'm going to do right now, because you guys are going to give me full credit for having written that. So part B says, now let's do the third degree Taylor polynomial. Well, the good news is that the third degree just builds on to the second degree, so I can rewrite my first 3 terms and add on my third degree term, which has a derivative of 4, x minus 1 cubed over 3 factorial. And I can clean up that last term if I choose to, and I do choose to right now. So x minus 1 squared, and then 4 over 6 will be 2 times x minus 1 cubed over 3. So this is my third degree Taylor, and if I'm going to approximate f of 1.2, what I need to do is sub in 1.2 for each x value, and I am not going to multiply them out because I don't need to. And I'll let you guys do that if you so desire to. So let's see if I can, that's a plus sign there, that's a 3 there. So I've plugged in 1.2 for each of the 3 x values. Then part C says, write the second degree for f prime. So the way to get the second degree for f prime is to differentiate the third degree for f, which we just did in part B. So if I differentiate this, the 3 goes away. From the second term, I'm left with just a negative 2. From the third term, I get 2 times x minus 1. And from the final term, if I bring down the 3, I get 2 times x minus 1 squared. So that is the second degree Taylor for f prime. And if I use it to approximate f prime of 1.2, what I need to do is sub in 1.2 in for each x value. Oops, hold up. Let me fix that. So 1.2 minus 1 squared, and I'm going to go ahead and leave it just like that. And that is your answer.